Okay, so for problem number 7, I wrote down the equations from our equation sheet. So these are all available to you during a test. Your volume of a cylinder is pi r squared L, and your surface area of a cylinder. And this is just focused on the outside surface area, not the ends of the cylinder, so just the curved parts here. This is 2 pi r L. And the radius that we're working with is not the radius of the actual rod, I'll call that big R, but it's just the radius of this cylinder right here. So this is little r. Okay, so let's start with finding the electric field. Obviously, we start with Gauss's law here, and we've got EA, so this is for part A, is equal to Q enclosed, because we're on the inside of the rod, epsilon naught. Now, they gave us rho, and that's charge over volume, so we know that our Q enclosed is going to be rho times the volume of the inside cylinder, and this would be the length of our, L would be the length of our inside cylinder. So that's going to be rho pi r squared L. And then I'm going to just plug those into our equation. E times the area, 2 pi r L, is equal to rho pi r squared L over epsilon naught. And then we can start reducing the the pi, the r reduces down to 1, and the L. And then we can solve for our electric field, which is rho r over 2 epsilon naught. For part B, they want us to drive the expression in terms of lambda. And so instead of rho, we're going to use lambda equals Q enclosed over length. And therefore, Q enclosed is equal to lambda times length. Now, our cylinder for this question is going to be larger than our rod. And so this is going to be my little r, and this is going to be my length. I'm going to continue. So this is for part B. I'm going to continue to use Gauss's law. Instead of our charge, we're going to use lambda L over epsilon naught. And then I'm going to plug in my equation for the area. 2 pi r L is equal to lambda L over epsilon naught. Reduce. And I get my electric field is equal to lambda over 2 pi epsilon naught times 1 over r. And I'm going to write it like this because I want to graph it. And when I'm graphing, I can see that our electric field, when r is greater than the radius of the rod, we have a inverse proportion, versus my electric field when r is less than the radius of the rod, we've got a direct proportion. So it starts with if I plugged in 0 here, it would start with an electric field of 0, and it would increase linearly as it approaches r on both sides, and then it would decrease exponentially for the inverse proportion once it passes the radius of the rod.